Okay, the line L1 has the equation x minus 1 equals to 2 minus y equals negative z. The line L2 passes through the point A, negative 2, 1, 7, and is parallel to the vector negative 3, 1, and 5. So it means that we see L2 actually has this as a direction vector. Okay, so first up, we need to write down the vector equations for line 1 and line 2, which is relatively very easy, right? So you have x minus 1, 2 minus y. X minus 1 equals to 2 minus y equals to negative z. Okay, you can quickly write this down, because here basically we are making lambda the subject, so this is like the Cartesian form. So quickly, in the equation of a line, you are able to convert from the Cartesian form back into the parametric form comfortably, right? Lambda equals to x minus 1, x equals to negative 1, positive 1, sorry, lambda, alright. Lambda equals to 2 minus y, y equals to 2 minus lambda, and z is just, there's no z also, it's just z. It's, okay, lambda equals to negative z. Okay, so that means z is equals to negative lambda. So combining these three, alright, for equation of line 1, you can see it's just equals r, which is x, y, z, is equals to 1, 2, and this is just 0, plus lambda, 1, negative 1, negative 1, alright, and with that, this will be your equation of line 1. So I hope you're able to do this. This is just a simple conversion from the Cartesian form of a line, equation of a line, into the parametric form. Okay, next up, for line 2. For line 2 is easy. Line 2 is quite straightforward. Line 2, alright, is it passes through negative 2, 1, 7, right, and is parallel to the direction vector negative 3, 1, and 5. Okay, so with that, part 1 is done. So you have your equation of line 1, you have your equation of line 2, right, so you are done. Okay, this is for 2 part 1. So how about 2 part 2? Okay, show that the lines L1 and L2 intersect and find the coordinates of E, the point of intersection of line 1 and line 2. So here, this is a very simple question. To show an intersect, of course, there are a lot of things. Number one, you can also, okay, first, if they just told you that they intersect, then do you also need to show parallel? Actually, you might not need to show, right? If they want to say determine whether they intersect or determine the relationship between the two lines, then you may need to show whether they are parallel. To show parallel means you take the scalar multiple. You should check the direction vector of both lines, see whether they are scalar multiples of each other. Right? Not show that they intersect means what you can do is already you can actually equate and show that there is a point of intersection that satisfies both equations of the lines. Alright, so that's what we will do. Alright, that's what we will do. Alright, we look at 1, 2, 0. Okay, so first one, equation of L1, right? This is on the left hand side, it is like 1 plus lambda. The y component is 2 minus lambda. The z component is minus lambda. This is for line 1. How about line 2? Line 2, the equation is negative 2 minus 3 mu. Is 1 plus mu. Is 7 plus 5 mu. This is on the right hand side. Okay, and you have equation 1, equation 2, equation 3. What next? So if they intersect, right, that means there must be a unique value of lambda and a unique value of mu that can satisfy all three equations. Alright, so I'm going to leave you to solve. The first one, very quick. I think a lot of you, whilst marking your assignment, you were able to do it easily. Right, so it's just first one, lambda equals to 3. Alright, and mu equals to negative 2. And you realize that you have to sum into 3. You have to check equation 3, because if you use the first two, doesn't mean that it satisfies the first two, means it satisfies the third one. Make sure you check equation 3. So for equation 3, you can see our left hand side, negative lambda. So check, when we check equation 3, we don't just write down equal sign. Check left hand side equals to negative 3. Right hand side, right hand side equals to 7 plus 5 of negative 2. It's also equals to negative 3. Alright, this is how you prove. Alright, we cannot assume equality from the start. So left hand side equals to right hand side. Okay, and see, oh, okay, from the first two equations, lambda is 3, mu is negative 2. Okay, then from there, I sum into the third equation, and it satisfies the third equation. So I can say that lambda equals to 3, mu equals to negative 2, satisfy all three equations. Alright, so with that, I can say that line 1 and line 2, they intersect. Alright, and what's the coordinates? So the coordinates, you just need to sub into either side. You can sub into lambda here, you can sub mu here. Alright, and so I'm going to sub into, I'm probably going to sub lambda. So right hand side, you can see x equals to 1 plus lambda, so 1 plus 3. Y equals to 2 minus lambda, so 2 minus 3. Z equals to minus lambda, so minus 3. Alright, so the power is just 4, negative 1, negative 3, right? Okay, I'm just going to erase all this. Okay, I'm not going to show you. So it's just it's equals to 4, negative 1, negative 3. Okay, and that is for part 2. So for part 3, the acute angle between line 1 and line 2 is denoted by theta. By finding cosine theta, show that sine theta is 2 square root 2 over square root 35. Now this one, it looks very difficult, but actually it's fine. Alright, so remember, if when we are talking about, the question told you, we are finding the acute angle between line 1 and line 2. Right? Remember that if this line on line 2 and this is theta, then remember in the formula or in the notes that you have seen before, line 1 is the direction vector m1, line 2 is the direction vector m2. What we're going to do is we take m, okay, the theta, cosine theta, is just equals to the modulus of m1, m2, right, over mod m1, mod m2, correct? Alright, so okay, I hope you recall what we learned. Right, so the direction vector of m1 in this case is what? It's negative 3. It's actually negative 3, 1, 5. Okay, second equation is 1, negative 1, negative 1. This is m2. This is m1, right? So I hope you remember this from just now. Okay. Okay, and with that, we can find cosine theta. Okay, so cosine theta, very quickly, remember to take modulus. A lot of students forget to take modulus. Okay, so modulus of negative 3, 1, 5, dot product with 1, negative 1, negative 1, over the modulus of m1. So it's just modulus of 1 square, 1 square, 1 square, square root 3. Modulus of negative 3, 1, 5, so it's square root 35. Okay, and with that, your answer should turn out to be 3. Okay, I mean it's going to be 9, square root 9 over square root 3, square root 35. Alright, and if I were to rationalize this by taking away the 3, I can multiply by 9 square root 3 over 3 square root 35, right? Right, and I can cancel off to give me 3 square root 3 over 35. So this is for cosine theta. Alright, so given cosine theta, how do we find sine theta? Okay, so there's a lot of ways to do it. One way is you can draw the right angle triangle. Okay, so another way, okay, very quickly, so you can say if this is cos theta, this is theta. Alright, 3 square root 3 I see as adjacent. Right, square root 35 I see as a hypotenuse, and very quickly I can say, okay, I can actually find out the sine. Okay, so this is one way, so I can find out the sine. Okay, so another way, right, a simpler way would just be to so you can maybe call this the opposite side. Okay, so opposite side is just equals to square root 35 square minus 3 square root 3 square, right? So you have 35. This is 9 times 3, 27, right? So it's just okay. And then with that, we know that this is square root 8. Right, so sine theta will be equals to opposite, which is square root 8 over hypotenuse, 35. And square root 8 can be written as 2 root 2 over square root 35. Alright, and we are done with part 3. Okay, last one. Hence, find the shortest distance from point A to the line L1, leaving your answer in exact form. So, point A is over here, right? This is negative 217. Want to find the distance from point A all the way to the line 1. Line 1, take note that this is the line R equals to 120 plus lambda 1, negative 1, negative 1, where lambda is real. So a direction vector that goes along this line be 1, negative 1, negative 1. Okay? What else do you know? Okay, we also know that A actually lies on line 2. So remember, this actually lies on line 2. So line 2, this is our line 2, correct? This is our line 2. So what would this mean? This is actually theta. This theta as we found, okay, so theta is the angle between the line 1 and line 2. Alright, what's the point of intersection? Again, from earlier, you know there is 4, negative 1, negative 3. So all these are information that you obtained from earlier. And with this, right, are you able to find what's the dotted line? This dotted line, let's say I call it D, right? This is the one we're trying to find, from point D onto the shortest distance from point A onto line 1. And how do we do this? Okay, I'm sure you have an idea, right, by looking at this. So first of all, I can actually take, I can actually do it in a very simple trigonometry format. That's first, I find out what is this. Okay, I recognize that this could be the, in this triangle, alright, I have H, okay, I have O, let's say, I have AE, right? Okay, let's say the length, I will look at this triangle, right? This theta, this part will be the modulus of AE. Correct or not? This is just the length of AE. This is the D, right? This is the the opposite. Okay, what else do we know from earlier? We also know that sine theta is nothing but 2 square root 2 over 35, square root 35, correct? And based on this triangle, you can see sine theta is nothing but D over AE. Alright, and what's the mod of AD? Of course, mod of AD you have to find. Okay, so here you can see that AE will be equals to OE minus OA, and you're going to get negative 6 to 10. Alright, the modulus of AE will be equals to let me see, you're going to get square root 140. Okay, so sine theta is equals to D over square root 140, and D will be equal sine theta, because it's 2 square root 2 over 35, square root 35, multiplied by square root 140, and eventually your answer comes out to be 4 square root 2. Right? And that's the end of question 2.